Okay, so here we go. This is an example. We are going to look at this simple truss that is under a load of 500 pounds. So first thing you need to do is, when you're looking at this problems is draw the truss and label the joints. So let's do that. So you have the joints here. This is going to be joint A, B, C, and D. Okay. So after you've got the drawing, the next thing we're going to do is check for static determinacy. So to do that, we are going to look at our formula. 2J equals M plus reaction forces, the members plus the reaction forces. So if we look at this, we have 2 times 4 joints equals 5 members plus 3 reaction forces. The reaction forces are as follows. We know we will have a reaction force at C. We don't know what direction it is, but we know when it's there. We have one at A and another one at A. So if we look at this, 2 times 4 is 8, 5 plus 3 is 8. We're good to go. Check. We're done with the first part. The next thing we're going to do is sum the moments. Okay. And when we look at this bridge, we have 2 moments. We have a moment at C, and we have a moment at D. D is going down, so that's going to make it go in a clockwise direction, which means that moment is negative. At point C, this has to respond to that downward force, so it's going to push up, which would cause a rotation in a counterclockwise direction, so the moment at C is positive. So we are going to write the moment at C is equal to, no, not equal, the moment at C minus the moment at D equals 0. So the sum of the moments is equal 0. Rearrange this to solve for moment C. And now we can find the reaction force at C in the y direction. The reaction force at C in the y direction times the length of that arm, which is 7 plus 3, equals the force acting in the downward direction at point D times the length of that moment arm. So we can rearrange this and solve for RCY. RCY equals 1500 divided by 10. 150 pounds. It's important to have a free body diagram somewhere that you can label so that you can keep track of what you know and what you're looking for. So in this case, we have a reaction force that is positive and opposite of the 500, okay? The next thing we're going to do is start looking at the forces in the y direction so that we can identify the other moment or the other reaction force. So for this one, the sum of the force in y is equal to 0. That means that the reaction force at point C in the y direction, which we know to be positive, minus the force at point D, which we know is negative, plus the reaction force at point A in the y direction is equal to 0. And we're assuming that A is positive. If it works out that it's negative, then that will be in our solution. So now we're going to rearrange this to solve for the reaction at point A. RAY equals FD minus RCY. And now we can just replace those with the numbers that we know. So we know that that reaction force at point A is positive and it's 350 pounds. So I've gone back to my free body diagram to label that. Next thing we need to solve for are the reaction force in the x direction. So the sum of the forces in x is equal to 0, and we only have one reaction force, or one force acting in x on this diagram, so that's easy. It's 0 pounds. So we know that this one is 0. Okay. So at this point, we have drawn the diagram, calculated or checked for static determinacy to see if the math will work. We did a summation of moments to find the reaction force at point C, and then we used the sum of the forces to find the reaction force at point A in the x direction or y direction, and then we looked at the sum of the forces in x to find the reaction force at A in the x direction. And then we've updated our free body diagram.